Hi everybody, this is your video for your Uniform Motion Part 1 study guide. We are taking the test tomorrow, Thursday, October 5th. The first question on here is, what do each of the following symbols mean? And so I'm going to slide this paper one at a time. For letter A, we have delta X. Delta means change, and position is a symbol for position, so change in position. Delta T is change in time. XF means final position, while TF means final time. XI is initial position. TI would be initial time. X symbolizes position alone, and then T is, of course, for time. When you see an M by itself, or when I see an M by itself, I'm going to assume it means meter. CM stands for centimeter. S is for second. And MI stands for miles. Down here we've got our absolute value bars with our delta X inside them, and if you remember that distance and change in position use the same formula, but when the absolute value bars are around it, it means we're calculating distance. Number 2, define uniform motion, which is also known as constant speed, and use the terms distance and time interval. So when I define uniform motion, I say that the object travels equal distance per time interval. And to use a picture to illustrate this, I drew dots kind of like the Play-Doh discs that we had during our battery car lab. If you looked at them, you would see that they were nearly an equal distance apart from each other. And in fact, if we were perfect, they should have been, to symbolize constant speed. Number 3, write the formula for change in position below. If we know the symbol for change in position, the symbol for final position, and the symbol for initial, the formula just kind of falls into place. Delta X equals XF minus XI. So change in position equals final position minus initial. Remember that your final position is wherever your object ends at, and your initial position is wherever it started. Number 4, the position of an object can only be defined relative to another object or mark or specified 0 point, which we've been using in every single one of our labs. We started at a 0 point. Number 5, define distance and write the formula to calculate distance. Well, distance is simply the total length traveled. Doesn't matter the direction, it only matters how far you went. So we can use this same formula, but the difference is we have to use absolute value bars, which means whatever answer we get, we turn it to a positive afterwards. For number 6, what is the major difference between distance and change in position? Well, we just saw that we use virtually the same formula. The only difference between them was the absolute value bars. Absolute value means that whatever you get inside those bars, if it is negative, you change it to a positive. So the main difference between them is that distance is never negative. So looking at this problem, I know that the front end of the faded car represents the initial position because it tells me up here in the directions if you really read. So I'm going to go ahead and make a mark at the front end of that car, and it looks like to me it is at positive 16, and that's my XI. But always include units, which in this case are kilometers, so km. If I go to final position, it's the front end of the solid car, so it looks like it's at 5 kilometers. My mathematical expression, no matter what, whether we're doing change in position or distance traveled, we're going to use XF minus XI. So change in position, I'm going to take 5, which is my XF from up here, minus my XI from up here, 16. When I do that, I'm going to get negative 11, which is in kilometers. And that's going to be my final answer, because change in position can be negative because it indicates direction. In this case, the car moved closer to 0, so it's a negative number. So moving to the left means negative in this case. Distance traveled, I'm going to do the same thing, only inside absolute value bars. So I'm still going to solve this, which gives me negative 11, but since it's inside these absolute value bars, I know I change it to positive, so it's simply 11. So down here, doing something similar, I'm going to mark the front end of the faded car, which is -9, and this is in meters this time. And then front end of the solid car, which is -22. Mathematical expression. The more times you write it, the better you remember. So this time we're going to do -22, which is XF, minus -9. Now I put the negative inside parentheses so that I remember to do this right here. When you subtract a negative, you add. So -22 plus 9 gives me -13 meters, which is fine because it's a change in position. For distance traveled, same thing. Okay, but inside absolute value bars. But here's a mistake that I've seen pretty often. You guys are changing this to a positive before you end, and you don't want to do that. You want to do the math first. So I still come out with -13 inside the absolute value bars, and then I need to change to a positive, so 13 meters. Okay. So, for number 8, on letter A, it says, what is the change in position between clock tick 3 and 5? When it asks you, what is the change in position, that should automatically tell you that you're going to use XF minus XI. The only problem now is figuring out what those two positions are. Now, when I go to clock tick number 3, I follow it up here, and there's already a dot, and I follow it over, and it lands right there at 8. Okay, so 8 centimeters. And then at clock tick number 5, I do the same thing. There it is. Follow it over. It's right at 12 centimeters. And since 5 comes after 3, I know that this is XF and this is XI. So I'm going to go 12 minus 8, which is going to give me 4 centimeters. My answer. And then letter B, what is the vertical intercept of your graph and what do you think it means? How does it relate to the setup of the experiment? Vertical intercept is where the graph intersects with this axis right here. So wherever your line comes and meets your y-axis, that is your vertical intercept. In this case, it's at 2 centimeters. And what that tells me is that that's where the object started. Which means it wasn't at 0 when we started the timer. For number 9, we're calculating the slope of each line. And looking at these graphs, they all start at 0, which makes things a lot easier for us. We can just do rise over run. And so I've solved these two. I use this point, which my rise is 40, my run is 10. So 40 over 10 is 4 meters per second. This one gives me 2 meters per second. And then C and D are 5 and 2. For number 10, we are supposed to calculate the speed first. And we can do rise over run again, and this is the point that I picked. So my rise is how tall it is, so it's 1, and then my run is how far over this way it is, so it's 2. So I take 1 over 2 and actually divide that out to give me a decimal, because we don't use fractions in this class. So 0.5, and then kilometers per hour based on my graph. We don't have to do that, kind of like in our homework. And then the position at t equals 3 hours, so I go over to 3 hours, follow it up and over, it gives me 1.5. Position at 2 hours is 1 kilometer, and the position at 1 hour and 20 minutes is approximately 0.70 kilometers. Units matter, guys. Don't forget them. That's an easy way to lose a lot of points. In fact, I've had people go through the entire test and put the units on their questions before they even work the math because they know that's worth points. Number 11, I realized I kind of messed up and it was a little confusing. So this graph is Andy and this graph is Robin. And letter A says how far from his starting point was he at t equals 5 seconds, and how do you know? So Andy is right here. So His starting point is right here at 4, and at 5 seconds, if we follow this up, follow it up, looks like he's not quite to 20 at 5 seconds. So, at 5 seconds, he was at 19 meters, and his starting point was 4. So again, I can do xf minus xi to find the answer. So if I know he was at 19 meters at 5 seconds, and he started off at 4, I'm going to subtract that, and it's going to give me 15 meters. How do I know? xf minus xi. Was his speed constant over the entire interval? Yeah, I know that it was because it's a straight line, number 1, so yes to the first question. And then if so, what was it? Well, this graph does not start at 0. It starts at 4. So that means I have to use our other slope equation. So xf minus xi over tf minus ti. And then where am I going to get those numbers? Well, here's where he ended up. So I'm going to use that point, and that's going to give me my finals. It's going to give me my final position, but it's also going to give me my final time. And this is where he started. It's going to give me my initial position and my initial time. So if I go to xf, follow this over, and I see that he was at 34. Okay. Then the initial position is where he started. We already know that that's 4. So my final time, this dot happened at 10 seconds, so that's final time. And then the time where he started was 0, so that's easy enough. So 34 minus 4 gives me 30 over 10, which gives me 3, but I'm not done yet. I need units, which is m over s, so meters per second. Constant speed of 3 meters per second. Next question says, Robin was further along at 2 seconds than Andy was, and does this mean that she was going faster? And explain your answer. Well, here's my answer. There's Robin and there's Andy up here. So Robin is there and Andy is there. It looks like his is a little steeper, but we're not for sure because our scales are different. So when I answered my question, I said, even if I don't know the speed, here's what it tells me. No, it just means that she was further from 0 at that point in time. Doesn't necessarily mean she was faster. She may have started 5 meters ahead of Andy, but it does not mean she is faster. It just means she's farther from 0 at that point in time. For number 12, this is the best graph that you could have made, okay? So I know that I need to get to at least 53. If I round that up, I'm going to go to 60. And so if 60 is my top number, I have 10 lines. I took 60 divided by 10. That tells me I need to go by 6s, so that's what I did along this side. And I labeled it position in centimeters, which is given to me right there, okay? And the bottom is always time, and it's time in seconds in this case from there. I plotted all my points, and then I took a ruler, which it is important that you take a ruler, and draw a straight line through those points. Then for letter A, what is the initial position? I'm looking at the very first dot, or you can go to 0 time and you'll see it. 3 centimeters. Letter B, what type of motion is represented by your line? You see a straight line here, okay? Straight line, which means constant speed, so there's your answer. So you see uniform motion, also known as constant speed. Letter C, what is the slope of this line? This line does not start at 0, which means we have to use xf minus xi over tf minus ti, which is what I've done right here. 5 centimeters per second is your final slope, which is the speed of that object. That's all for your study guide, guys. Study hard tonight. Good luck on your test tomorrow.